Have you ever wondered why you sound so good while singing in the shower? It is because of superposition. The sound waves produced by you in the air bounce off the walls and interfere with each other to produce a pleasing sound. Superposition is also shown by the ripples in a pond, waves on a string, or the noise-cancelling headphones you are so fond of. What is meant by superposition of waves? Basically, whenever two waves arrive at the same point, overlap and interact to superimpose on one another. Sometimes they add to make a bigger wave. Sometimes they cancel each other out, and often it is a combination of both. This phenomenon is known as superposition. And the wave produced by interaction of the two waves together is called the resultant wave. Waves are sinusoidal in nature, and they contain peaks and troughs that come in a pattern, one after another. When you superimpose the peaks of two waves, they add together to form a bigger peak. This is called constructive interference. And when you superimpose the troughs of two waves, they add together to form a bigger trough. They add together and flatten out to nothing, that is, to a flat line. This is called destructive interference. It's kind of like how -1 plus 1 adds together to become 0, the peak and trough cancel out each other. Aligned identical waves. While pure constructive and pure destructive interference do occur, they require precisely aligned identical waves. The superposition of most waves produced a combination of constructive and destructive interference and can vary from place to place and time to time. Mathematically, if we consider two waves, y1 equal to a1 sine omega t plus kx1 and y2 equal to a2 sine omega t plus kx2, then the resultant wave due to superposition is calculated as y net equal to y1 plus y2. Let's try a few examples to find the resultant wave. Question: two waves passing through a region are represented by y1 equal to 1 sine pi x minus 50 pi t and y2 equal to 1.5 sine pi by 2x minus 100 pi t. Find the displacement of the particle at x equal to 4.5 centimeters at time t equal to 5 milliseconds. Solution: according to the principle of superposition, the disturbance produced by each wave is independent of the other, and the resultant disturbance is equal to the vector sum of the individual disturbances. The displacement of the particle at x equal to 4.5 centimeters at time t equal to 5 milliseconds due to the two waves are y1 equal to 1 sine pi into 4.5 minus 50 pi into 5 into 10 raised to power minus 3, which is equal to 1 centimeter into sine 4.5 pi minus pi by 4. That is equal to 1 centimeter sine 4.5 pi minus pi by 4. On solving this, we get y1 equal to minus 1 by root 2 centimeters. Similarly, y2 equals to 1.5 into sine pi by 2 into 4.5 minus 100 pi into 5 into 10 raised to power minus 3, which is equal to 1.5 sine 2.25 pi minus pi by 2. That is equal to 1.5 sine 2 pi minus pi by 4. On solving this, we get y2 equals to minus 1.5 upon root 2 centimeters. Therefore, the net displacement is equal to y1 plus y2, which is equal to minus 0.35 centimeters.
Please like, share and comment on the video, and don't forget to subscribe to our YouTube channel. For more interesting and educational videos to earn while you learn, download Extraclass app from Google Play Store and get rewarded for study.